Okay, so the last of the sort of lessons I'm going to do on techniques in cytology. These are some magnification calculations. Okay, if you have a look on where is it? Page 24 of your notes in the pre-med, pre-dental notes, you'll find this conversion of units. Okay. Now it's important you're able to convert between units ideally from millimeters to micrometers, micrometers to nanometers, or millimeters to nanometers, and back the other way. So millimeters into micrometers. Well, there are 1,000 micrometers in a millimeter, so you multiply by 1,000. 1,000 nanometers in a micrometer, multiply by 1,000, and then divide to go the other way. Now, I've included on here centimeters as well. Okay, there may be occasions where you're given a measurement in centimeters. As soon as you see that, immediately convert it into millimeters. Okay, millimeters are much more useful. Try to measure everything in millimeters, never measure them in centimeters. That extra step, because it's not a factor of 1,000, tends to throw students off. And there are lots of students who incorrectly make that first conversion, which means that the rest of their calculations are wrong. So always measure in millimeters. Okay, I'll leave this up on the screen. I know this is, you can check your answers for your conversions in your table if you just pause the video now. Okay, but I'll move on. So an example of that then. So if we're calculating the size of a cell or a cellular structure, we need to use this equation where we use the image is equal to the actual size multiplied by the magnification. Okay, or you can rearrange that formula to find out the magnification. Usually the questions will either expect you to calculate the actual size, so the size of the structure before magnification, or calculate what the specimen has been magnified by. So the rules then to do that, 3 rules, very simple. If you follow these every time, you can't go wrong. So firstly, you need to rearrange the formula to find the correct value that you're looking for. So in this example, this blob represents a cell and has been magnified 100 times. How long is it actually? So we want to find the actual size of that blob in micrometers. We've been given the magnification of times 100, and actually here we've been given a measurement of the blob. But you'll notice the second rule is to always measure in millimeters. I said that already. So 3 centimeters is not good enough. We need to use 30 millimeters. And then the third rule is to convert the units into the units required. Now it will always state in the question the units required for the final answer. Excuse me. And in this case, that unit required is micrometers. So 30 millimeters, well, there are 1,000 micrometers in each millimeter. So that is 30,000 micrometers. We should have already rearranged the formula, so we know that the actual is the image divided by the magnification. So the image size is what we've measured, what is down in front of you on the page, 30,000 micrometers divided by the magnification that you've been given in the question. So 30,000 divided by 100, 300 micrometers. Okay. Now, if you follow those same rules with each one of these questions, you can't go wrong. So in your notes, you have this example. You are asked to calculate the actual size of an organelle, for example, a chloroplast, in micrometers. Okay. You are given its magnification, so the magnification is 30,000 times. Let's go back to that. So you should have that here. The image size, it tells you that the image size of the example is 90 millimeters. Let's just write that down. So we know that the size of that the size of the chloroplast on the question is 90 millimeters. Now, it's likely you would have had to use, where's the video? One of these, a ruler, to measure that. The rulers have millimeters down the side there. Use it, measure it in millimeters, use a ruler carefully. So, rule number one, rearrange the formula. What are we trying to find? The actual size, so we need the actual equals the image over the magnification. The image size is 90 millimeters. Rule number two, we've measured it in millimeters. Rule number three, convert it to the units required. So units required here are micrometers. 90 millimeters is equal to 90,000 micrometers. Divided by 30,000. I'm sure you could have done this. Divided by 3. So 3 micrometers. Okay, so the size of that chloroplast is 3 micrometers. Okay, another example then. Keep things interesting. Okay, here is a mitochondrion. In this question, a line has been drawn from one end of the mitochondrion to the other. So we've got from point A, B is a bit tricky to see down there, to point B. Again, you will need to use a ruler, emphasize this enough, to measure from point A to point B. Do it carefully, because with these questions, there is very little margin for error. There's very little tolerance in your measuring. It's expected that you can use a ruler, basically. So firstly, what are we trying to find out? So we want to know the magnification. So magnification is the image size. That's the one that you've measured, divided by the actual size. We've been told that the actual length of the mitochondrion between points A and point B in the photograph is 4 micrometers. Okay, now if you had used your ruler with this diagram, you'll find that if we measure in millimeters, that it's 84 millimeters from point A to point B. But we need to convert to the units required. We want to know in micrometers. So 84 millimeters becomes 84,000 micrometers. So that's our image size, 84,000 divided by the actual size, 4, gives us a magnification of 21,000. I actually allowed a little bit of tolerance with this question, so any measurement between 83 millimeters to 85 millimeters would have given you a magnification close to 21,000 times, and that was acceptable. Okay, but it's not a lot of tolerance. Tolerance of 2 millimeters, 1 millimeter either side. One last one then. Okay, another mitochondrion. This time we're being asked to calculate the actual length. So now, rule number 1, rearrange formula, actual is the image over the magnification. We know the magnification is 30,000. We need to measure the distance from there to there. It says the actual length. If it says length and there's no bar to guide you, find the longest part of the structure. And if you did that with this question, you will have found that that longest part was 94. We measure in millimeters and convert that to 94,000 micrometers, and then do the calculation. So actual equals the image size 94,000 over the magnification 30,000 is 3.13 micrometers. Okay, and that's some examples there of some magnification questions. They come up a lot. Learn how to follow these basic rules. If you follow those 3 steps each time, you can't go wrong. Okay, thanks very much. I hope that was helpful.